Hey guys, welcome back to Rocket Gyan, my fellow space tubers, and we are yet back again. And I think you are seeing a black screen. Let me just fix that for you. Wait, yes. Yeah. So we are yet again for another launch today, and this one again is very interesting because it's launching one of the Japan's lunar lander to the moon. And this is not only launching the lunar lander but also something else which is also very interesting. So we'll have a look at that too. Right now we are around T minus 54 minutes from the launch. Everything is looking good. Yes, it's known as a moon sniper. And I will tell you, we'll have a discussion about this, why this is known as a moon sniper, because the name is very much apt about the thing. So yes, this is a very interesting mission. Japan is known for weird missions technologically, something which no one ever thinks about it, and Japan wants to do it. This is one of those kind. So talking about today's mission, it is carrying two payloads. Not only this one, this is a slim which is going to land on the moon, and there is one more payload which is the XRISM, yeah, that's what they call it, which is the X-ray telescope. So they are launching two main payloads to space at the same time, which is so cool. Okay, so about let's talk about this slim lander first. But before that, let's have a look at the rocket which is going to carry today's launch. Okay, so we have this one. So this is the H2A rocket which is going to carry today's mission to the moon and to the, basically it's going to the low Earth orbit first. So it consists of, so it will have a H2A 202 configuration, which you can see. So in 202 configuration we have two boosters attached. So that is the thing. So here you can see that the first stage is powered by LE7A engine, which runs on liquid hydrogen and liquid oxygen as its fuel, produces a thrust of 1098 kilonewtons and a specific impulse of 440 seconds and a burn time of 390 seconds. So yes, it's a very big burn. Solid rocket boosters are produce thrust of around 2.520 kilonewtons. So kind of this big ass engine produces half of the thrust of this one solid rocket booster. So yes, SRBs are known for their thrust element. So there's that. Then we have the second stage, which is powered by again LE5B engine, which again runs on liquid hydrogen and liquid oxygen as its fuel, produces a thrust of 137 kilonewtons and specific impulse of 448 newtons. So this is the rocket which is going to space, and this is it's kind of modified for today's launch, because the fairing will not open like this in this mission. It will be open in half. So the length will be cut in half. The first part will open first and then the second part will open. I'll share you all the details with it, but yeah, that's how it would look like. So how are you guys? How are you excited for this one? Hey Wildflower, uh, hey Markle, hey Remiji, everyone going back to the moon. Come on, US, get back in the game. They have their lunar lander planned for the, I think the Viper mission is the one which is going to land a rover on the South Pole. So that is going to happen. This one is not going on to the South Pole, just for the kind information. So this is just going to the equatorial region, but this has a different what should I say, ball game attached to it. This is going to demonstrate a very high precision landing technology on a celestial object, which is the moon. So that's why it's known as moon sniper. They only have a landing zone of around 100 meters. That's it. This Chandrayaan 3 had a landing zone of around 4 kilometers by 2.5, but they have a 100-meter landing zone. So they are trying to demonstrate a very high precise landing on a very rugged or difficult surface. They have chosen a crater which is they are not going to land inside the crater but on the slope of the crater. So that is going to be very difficult to do, but yeah, that's how they have done it. So this is also going to carry two rovers. I won't say rover, but lunar excursion vehicle, which we will talk about. But yeah, that is the case. So basically it will demonstrate that part. So the weight around at landing will be around 210 kilograms, and dry mass will be 190 kg. You can see the landing accuracy within 100 meters. That's how they want to do. And they want to also demonstrate that lunar landing and lunar communication and lunar everything can also be demonstrated through very small objects. So this is going to a demonstration of high precision landing on the moon using a small probe, which is what they are going to do. And talking about the science of the mission, they first of all, they already have a lunar orbiter known as Kaguya, which revealed that the rocks, which is the olivine, thought to have erupted from the moon's interior, were excavated and exposed on the lunar crater slopes. So that is the one crater which they are going to go today. That crater basically has been formed very recently, so that's why they have chosen it, and they're trying to land over there. So yes, as all the Japanese mission, this is also a kind of cartoonish but fully technical. So there's that. First of all, let's have a look at their telescope, which is the X-ray telescope, XRISM, which is nothing but it stands for X-ray Imaging and Spectroscopy Mission. It is a JAXA X-ray astronomy satellite which will study structure and formation of the universe, outflows from galaxy nuclei, and dark matter. XRISM will function as a next-generation space telescope in the X-ray astronomy field, following on from JAXA's previous astronomy satellite Hitomi, which was lost prematurely. So this is going to be launched in the low Earth orbit, and this is X-rays space telescope from JAXA. Here you can see we have the star trackers, the mirror to observe that, and we have 6-meter fixed optical bench for the observation. Then we have the solar array, soft gamma ray detectors, extendable bench for JAXA, X-ray calorimeter, spectrometer, anti-sun radiator panel. So this is all it is. It's going to be around 550 kilometer circular orbit at an inclination of around 31 degrees. So this is kind of the telescope which they have made, which will observe the X-ray part, which is a very interesting thing. So X-ray astronomy it will do. They are launching two big science missions on the on this one. So hey John, welcome to the stream, and thank you so much for that 25, man. You are the person I always look forward to, and always make my day, man. Thank you so much. So yeah, John, keep it coming. That's what I would say. It really helps. All right, so this one is, yeah, we can talk more about this XRISM, payload and all, but more interesting thing is the lunar lander. So let's have a look at that. So this is the one, and this in front of you, you can see this is kind of very interesting. Most of the lunar landers, in fact I would say all of the lunar landers that we have seen, has engines facing downwards, and as everyday astronaut would say, when the pointy end is up and flamey end is down, then that's a good sign. But here the flamey end is on the sideways. What does that mean? Yes, this has a very weird landing, blah blah blah. they will land on the moon. So there is that. Now let's have a look at the mission profile. I mean the landing profile, which is very interesting. So they will be in a highly elliptical orbit of before the landing burn start, which will be around 600 kilometers into a 15 kilometers orbit. After that they will perform their power descent maneuver, which will decrease the 15 kilometer orbit to around 3.5 kilometers orbit. Then they will also have the vertical altitude descent coast phase, altitude hold phase, which will calibrate all the instruments, which Chandrayaan 3 also did over the lunar surfaces. And then they will at around 7 kilometers, this is around 3.5 kilometer, this is the one, they will have a vertical descent phase. In this it will perform that belly flop maneuver. So basically, first of all, what it's trying to do is, you can see, right, it will first kill all the horizontal velocity first, then it will drop straight down, then kill all the vertical velocity, and just above it will also have that hover phase and all, but just above 3 meters or something, it will cut off those engine and perform that belly flop maneuver. But just before performing the belly flop, it will also deploy those two lunar excursion vehicle, which is going to be really amazing. So there's that. I guess I am still online, right? Few minutes. Okay. I think we are good now. Yeah. Fine. Okay, cool. So I was saying that this is a very cool maneuver. Here you can see it will first kill off all the horizontal velocity, then drop straight down, kill all the vertical velocity, and then perform this belly flop maneuver. But at around 3 meters or so, it will cut off the engines and perform that belly flop. And just before performing that belly flop, it will deploy those two lunar excursion vehicle, which we will see. But here you can see this is how it will look like, that belly flop. Hovering will happen first, the forward inclination to do the belly flop, main leg touchdown which will happen, then the front leg touchdown will happen, and then the stabilization. They are doing this because, as I said, they are going to land on a very difficult terrain, a slopey terrain of around 15 degrees, and they want to ensure their center of gravity is as low as possible to maintain, to have as much stability as possible. So with the engines coming out, the lunar landers and all become very tall. And if we have a taller lunar lander or something, then the center of gravity also is above the surface of the moon. And as we go more up on the moon, the center of gravity goes more up on the moon, it becomes unstable. So to make sure that it is stable and has more surface area, we have this center of gravity which is way down as compared to in the vertical position. So that's why they are doing this maneuver. And this is very, very weird and very interesting. So yeah, that's how it is. So yeah, let's move on to the next part. So you, as I told you, right, this is a main leg touchdown will happen, the front leg touchdown, and they will be dropping straight down. So they want a proper shock absorbers on the landing legs. So this is the landing legs which will have the shock absorber, which will kind of absorb the impact during landing. It is different from what the Chandrayaan 3 had. Chandrayaan 3 had the dampers, but here it has some 3D printed mesh technology. Let's see this in action, how this will perform, right? And they are going for this circular landing leg, this shock absorber, because they don't know during the belly flop maneuver at which angle the leg will touch down. Having a circular spherical I would say the landing leg part, it will make sure that no matter at what angle it touches down, it will compress properly. So they have applied some brains over here. So hopefully this will be interesting to see. Now let's have a look at it and see how it looks like in action. You can see the compression, there you go. And then, whoa, just look at that. How cool is that, right? How cool is that? Look at that. Make sure that you can see actually, that mesh is also kind of flexible. So no matter at what angle it hits, it will try to be on, a proper compression angle to make sure the damping is proper. So amazing, and it's great to see like this. Okay, so now let's have a look at their. So they basically they are using a modified version of face recognition technology, which will try to recognize the craters on the moon and try to find how where it has to land and how it has to land. So this is one of those video which it's trying to do that only. So it goes over the moon trying to find its location. Once it finds its location, here you can see, right, still trying to find its location. This is simulation only, so there is that, but it will try to find its location. There you go. And once it has tried to, this is where it has to land. This is that crater which we are talking about, and at the edge of the crater, at the slope of the crater, it will try to land. Okay, now let's have a look at those interesting lunar excursion vehicle, or LEV 1 or and LEV 2, which is amazing. Okay, they are literally they are literally amazing. So the LEV 1 will move on the surface by jumping on it, like literally jumping on it. And the LEV 2 is a kind of a cute little robot whose main purpose is to uh, click photos of the lander and make sure it is going good. And it's a very cute little robot, and literally it's made by a toy company, which is amazing. So there is that. So minimum success is to demonstrate the deployment function of the SLIM spacecraft and to acquire data related to landing condition of the SLIM spacecraft, demonstrate autonomous functions and locomotion technology on the moon. And extra success will be to obtain information on landing status of the SLIM spacecraft and the area around the landing site. So we have, this is how it is look like. The LEV 1 is here and the LEV 2 is around here. So LEV 2 you can see around 250 grams, that's it. 2.1 kg is the weight of the LEV 1. So here you can see the LEV 1 is going to have a direct communication with Earth, which is amazing. And it's going to be moving on the rough terrain, and it's going to literally hop on the surface. It has a spring loaded mechanism on it, and it will try to hop on the surface. And during the free fall only, the separation will happen for the lunar excursion 1 and lunar excursion 2, and it will try to jump on the surface and try to acquire the data. So this LEV 1 and LEV 2 basically has this purpose only, that to acquire proper images. It has AI loaded over it so that it automatically detects the proper lighting of the area where the lighting is proper, click the photographs, so sorts the photographs from it, and selects the best batch coming from those photographs, and send it back to the Earth. So this is very interesting little experiment. This is not the first time Japan is doing something weird like this. It is very much expected from them, and yes, this is what they are doing it again. Talking about the LEV 2, it is a two-wheel drive. It will be deployed as a a closed one, a ball kind of structure, and then it will be opened. So it will send images of the SLIM spacecraft and surrounding to LEV 1. It has around 2 hours of activities, and LEV 1 has around 40 minutes of activities. So it will try to acquire as much of data as possible around that time. So these are certain things which it has. You can see it has this thing, this piston kind of thing you are saying. It will help in the jumping of this LEV 1. So yeah, this is how it is. Very, very interesting. Very, very interesting. So yeah, let's have a look at the LEV 2. So that's what I was saying. It will deploy literally, Transformers movie, Star Wars kind of thing. It will be deployed as a ball kind of structure, and then it will once it is on the surface, it will open up to expose these cameras, which it has front facing camera and the rear facing camera, and then it has this stability, what should I say, stability tail. Yes, stability tail, which will make sure that it is going properly. So and this one, the LEV2, is made from a toy company, I think Tommy Corporation or something. But yeah, exciting days ahead. So yes, this is the one. It is nicknamed as Sora Q. So this is the thing, around 250 grams of weight, one front and one back camera. That's it. Nothing, does not have anything else. It will actually, it will be talking to the Lev 1 via Bluetooth, literally via Bluetooth. It will be talking to Lev 1, and Lev 1 will have a direct communication with Earth. So it will send the data to Lev 1, and then the Lev 1 will send data over to the Earth, and they both will talk with each other via Bluetooth. How crazy is that? Literally. So there's that. You can see, right, automatically select the best quality images from the captured images and send them to the ground via Lev 1. Evaluate the results of running on the lunar surface from the data of the IMU and the encoder installed on the Lev 2. So this is amazing, literally amazing. So let's have a look at the video of this cute little Lev 2 or the Sora. The next thing is the science. So it will basically for the SLIM mission, right? This wait a second. Yeah, so the SLIM mission is going to go to the moon, where it's supposed to have near the crater where this olivine material is there, and it will be equipped with the multi-band camera to investigate the composition of this olivine, which is supposed to be coming from the inside of the moon. So we'll get to know more about what is inside of the moon. So this is what is exploring the origins of the moon. That's what they want to do. So there's that. Now what else do we have? Yeah, this we already have talked about. Look at this cute little animation over here. When we go down, right, it moves, it does a belly flop, and then again start its engine attitude. So this is what the mission profile is. It will kill off all the horizontal velocity first, then it will do this attitude hold phase to calibrate its instrument, then again do one of to kill all the vertical velocity, and then again do the belly flop. How cool is that? And yes, they have made sure that what should I say, wait a second, they have made sure that weight is also very much less on this one. Now this video summarizes the SLIM mission, so just have a look at that, and then we'll move on to the live stream. Can see that mission profile, in the trajectory, the Earth flyby and then the lunar flyby. Finally at the arrival, will stay there for around 1 month on the moon itself to observe the moon, navigation using the onboard camera, as I told you. And then finally it will on the landing day, it will kill off all the horizontal velocity, which you can see. Then it will do a rotate to the vertical position. This is the attitude hold phase. Try to calibrate its instrument for the lunar surface. Then it will again try to bring on its engine. Then obstacle detection will happen. Here you can see it found the perfect landing spot. Then it will retarget to that landing spot using thrusters only. Then again do one final burn, but before that it will deploy the lev 1 and lev 2, and then finally a belly flop maneuver. How cool is that? How cool is that? And this is the lev 1 and lev 2. You can see now how it will operate. See, this is how it will jump on the surface. How cool is that? And this is the lev 2, which will basically open up, as you saw, the sonar cube. And yes, it will make some optical observation of the surface. And there's JAXA for you. A little bit different. I think that's what their motto should be. Always they do something very extraordinary only. So I think that should be it. We have already talked about this one, so let's go away with this and quickly have a look at the flight profile. So yes, this is the flight profile. The liftoff will happen first. The SRB will separate. The first stage will be on the, you can see now, that's what I said, the upper satellites fairing separation. So it will have two stages. The fairing separation will again happen in two stages. The fairing itself is divided into two parts. First, upper one will be deployed, then the MECO will happen, then the second stage engine will start up. Then the second stage engine will cut off. The XRISM satellite, which is the telescope, the X-rays telescope, will be deployed. Then the lower satellite fairing will be deployed, which is amazing. The adapter also will be deployed. Then the second stage engine will start up. Again, the second stage engine will be shut down, and the SLIM will be deployed, which is the lunar lander. So yeah, that's how it is. And yeah, I think that's it. Let's move on to the
seconds after the launch. So that is the explanation in regards to the flight plan. And we'd like to give some information about XRISM and SLIM to be launched today. So first of all, there is a message from the XRISM project manager, and so this is an introduction of
for this one. Hey, Shri Sadhita, how are you? Good morning to you. Oh, the launch has been cancelled. What the hell, man? F's in the chat, guys. F's in the chat.
As you can see on the screen.
Oh God.
The launch today has been cancelled. Details for the future will be announced by the Mitsubishi Heavy Industries, as you can see on the screen. Because of the inclement weather, the launch today has been cancelled. For future the information this will be provided by Mitsubishi Heavy Industries.
It's very weird. I mean, Okay. The music was there, no? All right, all right, all right, all right, all right. All right, all right, all right. Thanks for that. I have made sure that is not supposed to happen. I think this is also good, and now it's fine. Actually, I was supposed to. Tomorrow is my work day, and I was supposed to. I thought I'll do this thing now, and we'll have a good one. But unfortunately, now I stayed awake till this. Now it's 5:30 a.m. and it was of no use. But I know this is the part of what I do, so it's acceptable. Hey, thank you so much, Mars 2028, for that too. Hopefully, it will go next time. So yes, hopefully it will go next time only, because we rocket nerds know that this cancellations scrubs are very much built into the system. So this is how it is. We have to, be ready for all of this. So yesterday also it was cancelled because of the weather, but they did inform us before the live stream, which was supposed to happen, I mean a day before only. But today they just informed after they begun their live stream, also their official live streams. So it was kind of weird, but yeah, that's how it is. Yeah, thank you so much, John. You can yes, I'll also go, but yeah. So talking about let's have a look at things which is there. So Chandrayaan 3 has dropped some of the results of the lunar surface, which is amazing, and you can see that there is a drastic. This is the chaste payload, which is responsible for measuring the thermal properties of the soil, and it has 10 sensors, and it has a drill which can go till 10 centimeter deep into the soil. It has 10 sensors, individual temperature sensors over it, and it takes the reading of those soil. So here you can see the graph. Literally at the surface it's around 55-60 degrees Celsius, and as you go down till 8 centimeter down, it drops to minus 10 degrees Celsius. This is huge. Like literally you can see, because of this, how insulative the lunar soil is, and because of that we can say that we can use the lunar soil to build our habitats also. And this temperature gradient, if we have this much of temperature gradient, we can also harness this temperature gradient to produce electricity, which is amazing, literally amazing. We not only have to rely on the solar panels, but we can also extract this temperature gradient to produce you know electricity from thermoelectric generators. So that is literally amazing. And if you haven't already seen those videos and photos that Chandrayaan 3 has published, so let me showcase that to you. So where is it, yeah, there you go. We have the rover and the solar panel deployment of the Chandrayaan 3. Here you can see the rover, solar panel deployment. Here will also you will see soon. This is literally amazing. How cool is that? That India now even has a rover out there. So yeah, and this is the video of the rollout of the Chandrayaan 3 rover. You can see a jerk was there because it was held by some motors, locking mechanism basically, and then it was released. Those locking mechanism was released. Then it after the release of that locking mechanism, it was held by a coil system, which is there rotated around that wheel, the back wheel, and then it started descent. So that descent is also controlled descent. It is using all those 6 motors as well as a cable which is holding it, so that there's a controlled descent over the surface. And yes, there is a big crater, but ISRO decided to go over it only. And yes, in on other videos we could see that it was going up. So yeah, these were kind of certain things which were there. So yeah. I think guys, we will now catch up again. I think if they they will most probably launch tomorrow only, so we will catch again tomorrow. So thank you so much for tuning in. I really hope that we will get the lander tomorrow, sorry, the launch tomorrow to the moon, and that space telescope also, the X-rays telescope also, we can see the launch tomorrow. So until then, this is Pianshu Roila. You just saw Rocket Gyan. Stay safe, stay healthy, and bye bye.